Morning. So for actually, we already finished on chapter 1, which map to the LO2. LO2. So if we look on the assessment, so on the assessment here, so for chapter 1 is actually a map to the LO2. LO2. So we already finished on the midterm test. And then another coursework mark is from the assignment 2, 5%. Okay. And then you also have 2 questions in your final exam. So the first question is about the design using the root locus method, which is either let, lead, or let lead. Okay, and the other question is design the PID controller using Ziegler Nichols. Okay, Ziegler Nichols, satu soalan, 15% mark, and another question is the design via root locus method, which is a let, lead, or let lead. Okay. But for today class, so we will discuss about assignment 2, 5%. So you can download the question from you learned under assessment. So here is the assignment and also table 1 and also the real physical circuit for active compensator. And this is a group assignment. So one group consists of 2 or 3 persons. And the deadline of this assignment is on 14 June. But don't worry, I will guide you how to do this assignment. So maybe you can submit this assignment before 14 June. Okay, for the group assessment, so you need to choose your group. So you can choose your member of your group that you comfortable to work. So at here under group, so section 2, so please choose your group assignment. So the maximum of one group is 3%. 3%. So later on, please choose your members or your group. Okay. Okay. So if we look on the assignment, the question of your assignment 2. Okay, assignment 2, so there is 2 parts. So you need to answer part A and part B. So part A is actually only cover on the Ziegler Nichols, how to design using the Ziegler Nichols first method. And this part is very important. So make sure you can do, you can design the P, PI, and PID using Ziegler Nichols method, because this part will be asked again in final exam, in your final exam. So make sure you can do this part A, and also part B. So part B consists of Ziegler Nichols and also the lead compensator. So you need to design the Ziegler Nichols approach. But for Ziegler Nichols approach for part B, so we will use the second method. And then you also need to design the lead compensator and do make a comparison between Ziegler Nichols and lead methods. But for today's class, so we only discuss on part A. So I will cover part B on our next class. So actually we need to replace the Monday class. So I propose this Friday afternoon. Boleh? We will do online. No need to come to the class. Online. Ada kelas tak? Friday. Friday 3 o'clock. Only 1 hour, about 1 hours only. Boleh? Friday ni. Kalau tak boleh, tak apa. Saya record ni sebab kita buat via Microsoft Teams. Boleh? Okay. Sebab kita dah week 11 so you only have another 3 weeks. So two weeks with Dr. Harry, and for the last week with me. So I will do the revision on your final exam for the week 14, on the week 14, okay? Okay, before we discuss on the part A, assignment 2, so I would like to do some revision on Ziegler Nichols. Ziegler-Nichols. So I already upload in YouLearn the notes, the extra notes or the more detailed notes on Ziegler-Nichols first method. First method is very important. So you can go to under week 11. So revision Ziegler-Nichols first method. So later on I will upload the revision Ziegler-Nichols for the second method. But for your final exam, so please focus on the first method. Okay, basically for the Ziegler-Nichols first method, we we apply this first method on the first order system. So please bear in mind. So Ziegler-Nichols first method basically for the system for the typical of plant that made up of a series of first order system. Okay, so that's why. So if we look at the output response for this system, so it look like the first order system, but with delay, dia ada delay sikit dekat sini. Okay, and from the output response of the system, so we can determine the parameters. So that there is 3 parameters, the 3 important parameters that you need to determine, which is a K, L, and T. So after you determine this value K, L, and T, so you can also determine the transfer function of the system. And later on, you can design the P, PI, PID using the Ziegler-Nichols. Okay. So now we look how to obtain or how to determine all these parameters K, L, and T. Okay, this is the table that are given that we will use to design the P, PI, and PID for the Ziegler-Nichols first method. Okay. So I will show you how to determine the value of K, L, and T based on this exercise. So this is the open loop test. So open loop test, and you need to suggest or you need to design the parameter of PID controller to obtain a quarter amplitude of closed loop response. So quarter amplitude of the closed loop response means that we will use the Ziegler-Nichols method, Ziegler-Nichols method. And the full scale change in temperature measure is 10 degree Fahrenheit. So that's mean, so our aim for this system is 10 degree Fahrenheit. And then you need to prove your PID controller that have been designed using the MATLAB simulation. So this is the table that we obtain from the open loop test. So we have here time and temperature. Okay, so first, so you need to plot the graph temperature versus time. So kita ada data, so we have data, so we can plot the graph of temperature versus time. So y-axis temperature, x-axis is our time. And then first we draw the C final line to obtain the K value. So C final line is here, kat sini. So here is our final value. So you just draw the C final line. So from here, so we can obtain that our K is equal to 9.4. So kalau jawab 9.5, 9.3, we still can accept. Okay. So dekat sini, so I put my value of K is equal to 9.4. Okay, so first draw this line. Second, so we draw the tangent line. So the tangent line must be crossed the x-axis to determine the value of the delay time or the parameters L. So it is obtained from 0 until the cross value of the tangent line and x-axis. So how to draw the tangent line? So you just draw the line that macam mana? Yang boleh sentuh lah banyak values data on this part kat sini. Okay. This line until it cross the x-axis. So draw this tangent line until it cross the x-axis. And the value from 0 until the cross value here is the parameter of L. That is our delay time. L. Boleh? Boleh? Boleh. Cross negative. Tak ada. Sebab our data is always on positive side. Mesti positif. Takkan dapat negatif. Tak boleh lah. So must be cross dekat positive value. Mesti positive value. Okay. So this is our second parameter L. So next step. So we will draw a vertical line. So a vertical line is the crossing between the tangent line and the C final from here. Here. Until it cross the x-axis. We draw this vertical line until it cross the x-axis. And the value or the distance from here until here is known as our t value or time constant. The distance. So dekat sini dapat dalam 9 point something. And then you minus with 1.4. So the t value is equal to 7 point. Okay. So after we obtain all this value, K, L, and T, so you can determine the transfer function of this system. So using this formula, the general formula. So I think this formula is not given in your final exam. So you need to memorize this general formula. Okay. So kena memorize. So please take note. So you need to memorize this general formula. K exponential minus LS over TS. So we just substitute all the value of K, T, and L that we obtain from the graph. So we can determine the transfer function of the system. So basically, before this, so when we talk about the transfer function, so you only, so biasanya kita nampak macam ni kan, for the first order system. So we only see the system something like this, 3 plus S plus 3 for the first order system. But the equation here consists of the exponential nampak, exponential minus 1.4s. So this represent the delay time. So means that the output response has a delay time before it respond. Dia ada delay lah, delay time. So before the graph become as the first order system. So if we look at the transfer function that consists of the exponential, so we conclude or we know that this system has a delay time. Faham Dia ada delay. Kalau macam ni, without delay, so our output response will start from 0, so dia terus increase for the response lah. Okay, so actually this slide is not on your final exam. Not on your final exam. So but you need to do this graph for your assignment. So plot the transfer function obtained in MATLAB. Okay, so actually there is a lot of way to plot the transfer function. So before this, you already learned when we want to plot the transfer function. So we declare the numerator, denominator, and then we find the transfer function, right? So this is this slide will teach you the other ways to plot the transfer function. Since because of our transfer function consists of the exponential term here. So we cannot declare the transfer function using the numerator, denominator, and so on. Okay, sebab dia ada exponential. So how to plot the transfer function using the MATLAB? So first, we need to declare S. So S, so this is the coding. S is equal to TF in the bracket S. Okay. And then we declare the transfer function directly dekat sini. So we can declare based on the transfer function from here. So we have here, so I name my transfer function as a G. So you can name it with others name, depends. So dekat sini saya letak G saja, G. So we have here 9.4 multiplied with exponential minus 1.4s. Okay, so I just put exponential first, exponential. You can also put 9.4 multiply exponential minus in the bracket minus 1.4 multiply with s. So it will give the same answers. Okay, exponential in the bracket minus 1.4 s, but for in the MATLAB coding, so we cannot the multiplication must be declared as a star function. So kalau ada multiplication, so you need to put star represent the multiplication. So minus 1.4 multiplication s. So we can use s because we already declared that s is the transfer function in this system. Okay, so multiply with 9.4 and then divide. So please be careful because we want to divide all this thing with 7.8s plus 1. So you need to put the bracket. Kalau tak letak bracket, dia akan baca 7.8s sajalah. So you need to put the bracket. So 7.8 multiply with s plus 1. And then you just press your enter. So it will give the answer like this. Okay, same. So, sama seperti transfer function yang kita dapat. Okay, actually without the exponential expression here, so kalau untuk normal transfer function, you also can use this kind of coding. So you can use this coding to obtain the transfer function, and later on we can plot the output response. Boleh juga kalau untuk transfer function yang biasa tu, so you can also use this coding of MATLAB to generate the step response of the system. Okay, so after we declare the transfer function, so we use the coding of step. Step means that we give the input of step input. Maksud dia, kita bagi step input for our system, step G. So, boleh? Okay. Okay, so this is the response that we can obtain from the step G. So kita boleh try. Siapa yang bawa komputer, so you can try. Give this coding. Ada dekat week 11. Nanti saya letak dekat assignment sebab macam awak confused Saya letak semua slide dekat assignment jugalah. Okay, so we declare as TFS. Then we have here exponential minus 1.4 S multiply with 9.4. Lepas tu kita ada apa? Uh, 7.8 tambah 1. 7.8 plus 1. And then step. Saya bagi nama, the name of my transfer function here is a G delay. Dapat tak? Run. Tak keluar. Kenapa? Oh, sebab saya tak tutup ni Okay, kat sini. So the same coding from the slide. So just the difference is the name of the transfer function. So I just give the name for my transfer function as a G delay. So after you write this coding, so you run. And then mana dia punya ni? Ni graph dia. Okay, so this is the graph, the output response graph that we obtain from the transfer function. So actually, from this graph, so you can panggil apa? Panggil apa? So we can edit our graph. So you go to the edit and access properties. So dekat sini awak boleh edit lah. So anything you can edit from here. So you need to so I will show you as an example. So let's we want to add the grids X grid and Y grid. So you just click. So it will show you the grid and the X grid and also the Y grid. So let's say we want to change the label, the x-axis label here. So we have here 0 until 15, 0, 5, 10, 15. So let's say we want to display the x axis here as a 0, 2, 4 increased by 2. So how to do? So you click at here. Kat sini, dekat teach. So you click this button. Then, so it will show you the XT and also the XT level. Okay, so we just delete the panggil apa? Kat sini kita just delete. So you add new values. Katakan kita nak increase by 2. So the level here is 2. So after that, we just click the plus. So dia akan automatic increase lah. So we will put it until 15. Okay. Boleh? So kita punya graph ni lagi detail sikit lah, nampak kalau kita plot. So after that, for in your report assignment, so you just can print screen and put in your Microsoft Word. So ini pun boleh tukar color dia. So kena explore, so you need to explore by yourself. Ini kan dia kelabu, so kita nak buat putih, so boleh tukar juga lah. So everything, so you can apa? Saya tak buat apa-apa pun. Okay. Okay, any question? Tak ada? Tak ada soalan Okay, next we continue on our discussion about the Ziegler Nichols using the first method. So this is the MATLAB coding to display the output response with time delay. So if we observe the output response here, so we have here delay, the delay here from 0 until 1.4. Okay, so after we obtain the transfer function of the system, so we can design the PID controller based on this table. This table is given, it's given in your appendix, so you just need to apply to use this table to find the value of KP, TI, and TD. So since that the question asks us to design the PID controller, so we just refer to this PID controller, this column, or this row for the PID controller. Okay. So for the value of TI, from this table, TI is equal to 2L. So L from the previous slide, so we already obtained that L is equal to 1.4. Okay, masuk saja nilai. And then we calculate the value of TD, 0.5 L. And the last one, we calculate the value of KP, 1.2 T over L. So let's say you want to design the PI controller, so you need to refer this row, this PI controller. So you will find the value of KP and the value of TI. Boleh? So after we obtain the TI, TD, and KP, so we substitute all this value into the general equation of the Ziegler-Nichols method. So I think this equation is also not given in your final exam. So you need to memorize this general formula for PID controller using the Ziegler-Nichols method. Nanti saya confirm balik. So what is the formula is given to you in your final exam. Okay, so masuk sajalah nilai KP, TR and TD. So we already designed the PID controller. Okay, so that's all for your theoretical. But sometimes in theoretical, so you need to design the value of K1, K2 and K3. So the value here, K1 is referred to the proportional gain. K2 is our integral gain. And K3 is our derivative gain. So actually all this value, all this relationship, so I already give you in the notes Ziegler Nichols. Ni, you boleh tengok balik notes ni on week 5 kat week 5. So we already obtained the relationship between the Ziegler Nichols and also the parallel form PID controller in parallel form. So from here, so the relationship that we obtain is the K1 is equal to KP, K2 KP over TR and K3 KP multiplied with TD. So nanti I will confirm again. Is it the formula is given or not given? But saya rasa macam dia tak bagi. So either you need to memorize or you need to prove by yourself. So we have here the PID controller from the Ziegler Nichols, and here from the parallel form. Parallel form is easy to memorize because parallel form. So we just add the proportional, integral, and derivative. Okay, so you just memorize the formula in Ziegler Nichols for PID controller. So KP 1 plus 1 over TIS plus TDS. Okay, so from here, so we can conclude that the value of K1 is same with the value of KP, K2 KP over TR and K3 KP multiply with TD. So saya rasa ni ada keluar dalam final exam. Benda ni direkod ni. Okay. Okay, so after that, we can plot the open loop and also the closed loop system with the PID in MATLAB. So this is the coding. So I will explain this coding. Kat sini. So the same coding. So first, we need to declare the S. S is equal to TF in the bracket S. And then here, so I declare the transfer function of the GPID. So that we obtained previously here. Dekat sini. Saya masuk je dalam kode ni, dapat ni, transfer function for the PID controller. So after that, so I write again the transfer function of the system without the delay. Okay, without the delay. So we add the delay later on, since that our discussion is the linear system. So if you remember for the linear system in signal system, ingat tak? Ataupun apa? Kita panggil apa? Tak ingat lah. But for the linear system, so if we give the delay to the input, so that value of delay we also occur at the output response, the output response. Okay, so that's why for analysis, so we just ignore first the delay, So we just write the transfer function without the delay. GPID and G. So if you remember the block diagram for the system with the PID controller. So here is our system. So we will connected our PID controller series or cascaded with the G. And then the output response will feedback to the input. And we have here the summing junction. So input, summing junction, plus, minus, here. And the output from this summing junction is the error. The error. Since that our aim is we want the value of output is equal to the value of input. Okay, so this error will go to the PID. So PID will try to eliminate this error until the output obtained here is equal to the input, or the error will become as a 0. Okay. Okay. So to find the output response of this system, so we need to find the closed loop of this system. So closed loop of this system. So PID series with the G. So that's why here, the coding here, so I combine series and feedback. So I have here feedback. And before we can do the feedback, so we need to series the PID and G. So that's why the coding here, series G and GPID. And then one here is refer to the feedback. Since that our feedback is a unity feedback, so we just represent our feedback with 1. Okay. So saya combine series G and GPID, and then feedback with 1, since that the feedback here is the unity feedback. Okay, so the next coding here is the so I put again put back the delay for the closed loop system here, and also for the open loop system T delay. So I name it as a T delay and G delay. So just multiply with exponential minus 1.4, multiply with S, multiply with T, and here multiply with G. And then we give the last coding is to display the output response. So we just give step T delay multiply with 10. So why we multiply with 10? Since that the final value in this question is 10. Kat sini, soalan ni. 10 degree Fahrenheit. So that's why we multiply the closed loop system with 10. Since the step here, when you give the step here, step refer to the 1/S. Dia akan bagi 1. But our final value is 10. So that's why we need to multiply it with 10. And then comma, because we want to plot both graph, PID with delay and also the output loop with delay. So kita just letak comma, G delay. So this is the step response that will display lah. Okay. Okay, so that's all for the Ziegler Nichols using the first method. Very simple, simple. So you just need to find the value of K, L, and T, and then you find the G transfer function, and then you just design your PID, P, or PI controller using the table. Itu saja. Okay. Okay, now we go back to our assignment part A. Assignment part A. So you are given an open loop radiator temperature reading during low and high speed of fan as in table 1. So the reading was taken for about 40 minutes. So this is just a statement saja. So we have here a table. for 40 minutes. So during 1 until 30 minutes, so the fan condition here is set as a low, and later on from 31 until 40, so our fan is goes to or is set to high. Okay, the question here, so you need to design the P, PR, and PID gains using appropriate industrial-based approach, or also known as a Ziegler-Nichols method. Okay, so from here, so that's mean we need to design using the Ziegler-Nichols method. But we didn't know because we learned to design the Ziegler-Nichols method, two methods, the first method and the second method. Okay, so how to decide which method that we want to use? First, we need to plot this apa? This output response based on this table. Kena plot kena plot. So I will show you how to plot the graph using the MATLAB. So you just ada biasa guna MATLAB betul tak? Kat sini, so you just click the script, new script. So kita akan tulis dekat M file, new script here. So since that we want to plot the graph, so we need a data of T and the amplitude or temperature lah. So first our T from this table, so our T start from 1 until 14. So they increase 1 by 1. So we just declare our T as a 1 until 40. So kita akan this is our data T until 14. So actually when you run this file, so you can see here at both workspace, so they bagi the data of our T from 1 until 40. So 1, 2, 3 until 40. Okay. Okay, so next we need to declare the temperature data. So temperature data. So from the questions, so temperature data is here, from here until here. Okay, kat sini. Tak tahu boleh copy paste tak data ni, but in your you learn. So I also give you the data in Excel file kat sini. So ada dalam Excel file. Tengok. So you can use this data in Excel file. Kakak ni boleh? Kat sini saya ada bagi table satu so you can open this table 1. Tak boleh copy lah this data. Just drag and then copy this data. Copy. And then go back to the MATLAB. So I name it as a Y. Y equal to, so kena letak matrix because in MATLAB all the data is read in matrix. So you just paste. Okay, dapat ni. Okay, so now we run. So saya clear dulu semua benda. Kita clear dulu. Clear all. Okay. So we run again. So in the workspace, so we have T and kenapa ada 41? Salah copy Loh je. So dekat sini 41, sepatutnya ada saya ni balik Kenapa ada 41 data? Sini 40 aja kan? Empat puluh satu Ada 41 Ada 1, 2. Oh, ada 41 data. So you just buang. Dekat sini pun ada 41 Oh, ada 28. So you buat you delete Boleh? Delete data 28 tu. Dekat 28 ni ada 2 kali. So you just delete. Okay. Should be 40 lah. Nanti saya upload new data supaya tak confuse. Okay, so kita copy again. Pada T1 multiply with 14. But for the Y here, so the data is 40 multiply with 1. So if you click the Y, so nampak the arrangement of the Y data dia macam ni. But the T is macam ni. When we want to plot the graph, so dia kena sama tau. So how to make it same here? So since that the Y data is the matrix so you ingat tak kita boleh tukar kan? So dia punya arahan dia adalah expose Tapi dekat dalam MATLAB coding, so you just put this symbol. Simbol kat atas ni nampak tak? Simbol comma kat atas. Transpose. So we run again. So we can see here. So the arrangement of T and Y is same. 1 multiply with 14, 1 multiply with 14. So after that, tapi senang kita ubah Y lah. Since that Y kita declare it as a matrix in matrix form. T tu kita declare it as T1 until 40. Tapi you boleh try lah. Saya pun tak pernah try. Tapi saya rasa boleh. So after that we want to plot the graph. So you just give the coding plot. Lepas tu open the bracket. So kita letak T dulu part C X dulu. So T and then comma Y. So just run again. So this is the graph. The graph that we plot from the table 1. Okay. So after that you can make up lah your graph. Boleh letak grid. So if you want to give a clear value for the T, so you can change in term of pergi dekat sini properties. Saya tunjuk tadi lah. So kita tukar ni 0 to the increase by 2 supaya kita boleh baca the data precisely lah. Okay. So if we view this output response, so the output response is look like the first order system. So ni kita tak tengok dekat sini tau. We didn't care about this data since that this data, so the fan is changed from low to high. So we consider it as a disturbance. So we just observe the first data here. So the graph here looks like as a first order system. So that's mean to design the PID controller for the task 1. So we will use the first order method. Okay, kita guna first order method. Boleh? Boleh? So from here, so you just boleh tukar lah dekat sini supaya dia nampak lagi ni. Mana copy? Here. dekat sini. So you just click at label. So kita buat increase by 2 by 2. And then you kena type first, untuk first data you need to type so after that you just click add. Tak boleh baca ni part. Until 40. So same goes to the Y label here. Untuk design, so we only look at the first class without disturbance. Apa tak ada? Apa label saya dah hilang? Oh, label kita tadi start from 20 Tak buatlah. Boleh? Saya tak tahulah. Dia dah pening kan? So after you obtain the graph, so you do the analysis. The analysis to find the value of K, L, and T. Macam ni. So just follow this step. This step to obtain the value of K, L, and T. Boleh tak? Okay, just print screen your graph, put on your Microsoft Word, and then you just draw the line. So follow this step to find the value of K, L, and T, determine the transfer function, and later on you find the value of you design the value of P, PI, and PID using this table. Boleh? Boleh? Boleh tak? Cepat-cepat sikit. Mana? Okay. So ni tak ada masalah. So you can design the P, PI, and PID case. So that means we have three controller. So you need to design the P controller, the PI controller, and the PID controller. Okay. So after that, determine the P, PI, and PID against parameter, which is a KP, KI, and KD. So ni you need to find the value of K1, K2, and K3 using this relationship. Kat sini. Okay. Tadi you already obtained the value of KP, TI, and TD. So after that, in calculation, so find the value of K1 or K proportional, K2 or K integral, and K3 for the K derivative. So ni buat calculate saja using that relationship for the KP, KI, and KD or K1, K2, and K3. Okay, boleh? Saya boleh? 1, 2, 3 boleh? 2, 3? Boleh? Ni boleh tak? Okay, so next So you need to plot the open loop and PI and PID compensated response in the MATLAB. So discuss your results. Okay, so now we need to plot four graph, four graph open loop, the system with the P controller, the system with the PI controller, and also the system with the PID controller. Okay, so from this coding, so here, so I declare all the transfer function without the delay, So we have here the open loop system G. GP here refer to the proportional value or proportional transfer function. And then we have here GPI and the GPID. So after that, we find the feedback system for the P, PI and PID. Dia sama saja dalam contoh tu, just you need to repeat it for P, PI and PID. Okay, so after that, we find the transfer function with delay. So we just multiply with the exponential minus LS for the TP, proportional, PI, PID, and also for the open loop system. So after that, we want to plot. So NM is a figure. So because I want to plot with different figure, so you need to put it as a figure step G delay. Kalau if you didn't put the figure, dia akan overlap the data. So you just only have only one figure. So because we want to generate 4 figures or 4 graph, so that's why you need to put figure, and then step G delay for the open loop. So the second is the TP delay for the proportional gain of P controller. So the next here step TPI delay for the PI controller, and the last one is the PID controller. So we need to multiply with 15 since that our final value for the for the temperature control is the 50. So that's why for the closed loop system, we multiply with 15. So after that, you run. So we have here 4 figures. Figure 1 is our open loop system. Figure 2 refer as our P controller, and figure 3 PI, and figure 4 PID controller. So from this figure, so I want you to obtain the settling time and the ESS, only 2 values. Settling time and ESS. So you just right click here, goes to the characteristic and click the settling time and also the steady state values. So settling time and the final values. But I want you to find the value of ESS. How to find the value of ESS? So use this formula. 50 minus final values. Kenapa 50? Because our input is a 15 degree, 15 Celsius, 50 Celsius. So that's why the ESS is referred as a 50 minus 40 final values. Okay, same goes to the figure 2, figure 3, and figure 4. Okay, so you just print screen all this graph and put in your report. Okay, so you can make a table for the open loop P, PI, PID, and give the value of settling time, and the ESS. And then you compare lah. So which one is the best controller based on the settling time and also the ESS. Boleh? So that is your discussion. Okay, boleh? Okay, so we finish on the number 4. So for the number 5, so then demonstrate in MATLAB Simulink by giving a step disturbance 0 until -10 at minute 13 and discuss your result. Sekarang kita akan guna Simulink. Simulink. Biasa guna tak Simulink? Pernah guna kan? So you can create you can open your Simulink file dekat sini, dekat new. Bukan dekat new, dekat open. Open. Open pula dekat mana? Dekat mana? Dekat mana? Dekat home, dekat new Simulink model. And just choose the blank model kat sini. So lepas ni kita akan draw our system in the Simulink. So ini saya dah draw, saya tak tunjuk. Saya tunjuk start daripada awal. Okay, so we want to plot the diagram of the open loop system. So we need the transfer function. So you just can type here, or you can use the library browser. So just type the transfer function, dia akan keluar. So just double click, so dia akan keluar the transfer function of the system. Okay, and then we will give the step input. So you just click the step, so dia akan keluar step. So sambung. And then we want to display the output response using the scope. Kat sini. Okay, so the step here. Ni tak ada masa ada kelas kan? Pukul 10. Saya terus tunjuk yang saya dah draw. So here, so this is the open loop system. So draw open loop system here. So for the open loop system, so the start time is 1. It depends on the delay values. Your delay values. Kalau your delay value is 1.4, so you need to put it as a 1.4. Okay, so from 0 until 1. And then this is the open loop system. So so you need to put your numerator coefficient and denominator coefficient. So don't need to put the delay time since that we already give the delay time at here. Okay, so just put the open loop system without the delay, without the delay or without the exponential. And then because we add a disturbance, step disturbance, so we put the summation here, and this is the disturbance. So our disturbance is at time 30. So you letak 30 in the question. Our disturbance is at time 30, and then the final value for disturbance is from 0 until -10. Okay, and then this is the scope. Okay, so we repeat this system, this is the open loop for the P controller gain. So for the P controller, so we just put the P controller as a gain. So you just boleh type gain. So dia akan keluar lah. So after that you double click to change the value of gain. Okay. And this is the system. Okay, since the system here is the closed loop system, so we need to draw the closed loop system at here. Okay, and add the disturbance, the same disturbance value from here. So this you just copy sajalah, copy, put at here. Alright, kat sini. And then for the step input here, okay, so we need to put as a 15 for the final values for the closed loop system. So kita kena letak 15. Dia berbeza compared to the open loop values. 15. Okay, the same delay time. And then repeat with the PI controller. So the difference is only the controller here. So we just use the PID controller. So you just can type the PID. And choose the PID controller. So if you double click this PID block diagram, so we have here the value of proportional, integral, and derivative. So this value refer to the value of Kp, Ki, and Kd, or K1, K2, and K3. So if you want to use only the P controller, so you need to set the integral and derivative as a 0. So maksud dia akan jadi P. Okay, kalau if you want to use the PI controller, so you need to set the derivative as a 0. Kat sini kita letak values lah. Okay, depends on from your theories. So what is the value of P and what is the value of I? Faham ? So this is the integral and the same block PID controller, but for the PID controller. So you can see here, so I put the value of D. So that means this is the PID controller. So yang lain adalah sama. So another drawing here is the multiplexers. So you just can type MUX. So because we want to display all this graph, all this output response in one scope. Kat sini. So you boleh, you can double click and set the numbers of input since that we have 4 inputs. So that's why I put as a 4. So the first value here is the open loop system from the open loop system. So actually you can name kat sini. So boleh give the name. So you click, when you click this connector, so you can write the name of this connector. Okay, open loop. And then for the second here is the P controller. So the same point, output. So I put the name is a P and then PI and PID. Okay, so next you can run okay, so we can observe the output response here. So basically there is no legend. So you need to go to a view and click the legend here. So we show you the name. The yellow one is the open loop. The blue one is the P, PR, and PID. Kalau letak dekat sini, the name is here. Kalau letak, let's say, kita letak ni sebagai K. So when I run this system, so nampak, the name here is K. Faham tak? Faham So after that, you need to print screen this result. And also after that, you need to zoom. So you go to this scope, zoom. So zoom at here. So when you zoom at here, so we can see which controller is better. So nampak kalau dekat sini, which controller is better, the best controller, PPI or PID? PID, so the fastest controller that can eliminate the error. Okay, nampak kalau ini dia lambat, baru dia dapat eliminate the error, but the PID is the fastest controller. So that is your conclusion. Okay, so two graph from the Simulink. So the first graph, dekat sini boleh tekan kat sini, so dia akan keluar graph the full. So the first graph, so the second graph, so you need to zoom at the disturbance during when we give the disturbance. Okay, and then you discuss your answer. Okay. Dah. Boleh? Nanti awak buat I dengan T tu kosong. Kosong. Boleh? Ya, boleh. Okay, so the last question for the task part A. So you need to demonstrate how the PID compensator design above can be represented in real physical circuit. So ni pun ada keluar finals. Rasanya lah. Tapi makan dia tak banyak. So I already give you the notes how to implement or how to demonstrate in real physical circuit. So in MATLAB here, so you can see the notes real physical circuit for active compensator. So basically, so you already learn in theoretical how to design the PID controller, and then you simulate in MATLAB. So after that, when you want to build your PID controller in experiment, so you need to have the circuit, the physical circuit. So what we call as an active realization of the controllers. So ni this controller use the op-amp, and we have here two impedance Z1 and Z2. Okay, so the question here, so you only show the PID compensator, so that means we will refer to this block diagram and find the PID circuit. So PID here. So PID means that the Z1 here is referred as the C1 parallel with the R1, and Z2 here is referred to the R2 series with the C2. And this is the transfer function for PID controller. Okay, so I also give you the example how to demonstrate the PID compensator in equation 1 below. So you can represent in real physical circuits. So the answers, so we refer to this circuit and also the circuit Z1, and this is the Z2 and also the transfer function. Okay, we compare with equation 1. So this is the equation 1 that we obtained from the theoretical. Tadi yang kita dapat ni example bukan nak punya. Kalau nanti GPID ni yang you dapat dalam jawapan you tadi lah. So ni just an example. So we compare equation 1 with this equation. This equation 1 and equation 2. So from here, we can conclude that minus R2 plus R1 plus C1 over C2 is equal to 10. Nampak dekat sini. 10. And then R2C2 is equal to 5. 1 over R1 C2 is equal to 5. So we have here 4 unknown values R1, R2, C1, and C3. And then we have 3 equations. So to solve this problem or to find to design all these values, so we need to select one values. One values. So from this example, I select the C2 values. C2 values, then substitute the C2 values into the equation 3 and letak until you find all these value. Kita boleh dapat dah. So you boleh you go through for this example. So after that you will obtain the value of C1, R1 and R2. For the C2 we select dah. Yang ni kita select. So the others value we need to calculate based on the equation. In this equation, so after that we just can demonstrate or we can put the PID controller in the real physical circuit. So Z1 is represented by C1 parallel with R1, and for the Z2 series R2 and C2. So this is the final answer for task number 6. Boleh? Apa-apa value pun boleh. Basically the value yang the suitable values lah biasa kita select. Okay? Okay, that's all for now. So any question? Tolong buat ya, jangan buang masa. So balik ni terus buat. So for the next class, so I will show you how to answer the part B. Part B. Okay? So tak ada soalan eh? Saya stop eh. Afiq dah boleh keluar.